to solubility equilibria that I want to discuss is how pH can actually change the solubility of some substances. So pH is only a factor in solubility if one of the ions in your substance is either an acid or a base itself. So if one of the ions in your substance is acidic or basic, solubility will change with pH. So if one ion is basic, which many anions are, that means that your salt is going to be less soluble in basic solution than in water. Because of that basic ion. So remember that basic solution is high pH, so greater than 7 if we're at 25 degrees Celsius. And the reasoning for this can be explained by Le Chatelier's principle. So let's take magnesium hydroxide as an example. We know that hydroxide ions are basic. They're like our quintessential base. And what it means for a solution to be basic is that the hydroxide ion concentration is greater than the hydronium ion concentration. So in a basic solution, the concentration of hydroxide is greater than it would be in water. In pure water, it's around 10 to the minus 7th. In a basic solution, it's something greater than that. So this is essentially just the common ion effect for a base specifically. So we have more hydroxide, our common ion, present in solution, which means that our solubility is going to be decreased. Because according to Le Chatelier's principle, having that extra product in our solution is going to drive our equilibrium to the left. These types of compounds where one of our ions are basic will also be more soluble in acidic solution. So this is a little bit more complex in terms of the explanation, but we can still think about it in terms of Le Chatelier's principle and concepts that we already know and understand. So if we look at the same reaction, same substance here, magnesium hydroxide as our example, when it dissolves, it produces magnesium ions and hydroxide ions. So in an acidic solution, we have hydronium ions around that are going to react with those hydroxide. So the acid in our solution actually reacts with the hydroxide. When it reacts, that hydroxide is no longer there, so we're removing that product from the system. Oh hey, now this looks just like a Le Chatelier problem. If we remove product, our equilibrium is going to shift to the right in order to reestablish equilibrium. Right, or forward in this case, represents conversion of solid into aqueous ions, which means that more stuff is dissolving, or we have a higher solubility. So same principles of Le Chatelier apply here, that we're now decreasing this concentration by giving it something to react with, namely the acid. If we take this away, our reaction is going to shift to the right in response, which represents more stuff dissolving. So salts containing basic ions are generally less soluble in base, more soluble in acid for this reason. All the same reasoning applies for when one ion is acidic, just everything is reversed. So when one of your ions is an acid, your salt is generally less soluble in acidic solution than it would be in water. Due to a common ion type effect, and your salt is more soluble in basic solution because the base reacts with your acidic ion, removing it from solution and driving the equilibrium towards products, which represents more stuff dissolving.